Is artificial intelligence actually intelligent, or are we just building really impressive parrots? For years, we've been stuck in this endless debate. Is this AGI or not? But today, something has shifted. For the first time, we have a structured roadmap for measuring AI progress. A working architecture for intelligence that runs on devices smaller than your hand. And a clear path forward that might finally settle the question of what it actually takes to build a general intelligence. Welcome back. Today, we're diving into 3 papers that together represent what might be the most significant week in AGI research so far this year. We're going to talk about how the field is finally getting its own version of the autonomous driving levels, how researchers just got a general intelligence system running on a tiny edge device with 50 millisecond response times, and why the future of AI might not be a single approach, but a hybrid of everything we've learned. Stay until the end, because what this means for the timeline of AGI might surprise you. Here's the thing about artificial general intelligence that nobody likes to talk about. We've been arguing about the wrong question. For years, the debate has been binary. Is it Augie? Yes or no? Are we there yet? Can GPT-4 do this? Can it do that? It's like asking whether a child is human enough compared to an adult. The question itself is broken. That's exactly what the levels of AGI paper is trying to fix. Think about autonomous driving. Nobody asks, is this car self-driving or not? We have levels. Level 2 is lane keeping and adaptive cruise control. Level 3 is conditional automation. Level 4 is full autonomy in specific conditions. Level 5 is everywhere, anytime. Right now, we're somewhere between level 2 and level 3 for driving. Same thing for AGI. The levels of AGI framework proposes 5 levels: emerging, competent, expert, virtuoso, and superhuman. And here's the kicker: by their metrics, our most advanced systems today are level 1. Emerging, they're roughly equal to, or just a bit better than unskilled humans. Not yet competent, that's a reality check for anyone who thought ChatGPT was the finish line. But here's where it gets really interesting. While we're figuring out how to measure progress, some researchers are already building intelligence that works on devices you could hold in your hand. The Edge General Intelligence paper describes a system running on an NVIDIA Jetson Orin. That's a piece of hardware about the size of a paperback book that achieves 72% success on complex, long-horizon manipulation tasks. And it does this with inference latency under 50 milliseconds. For reference, that's faster than a human blink, which takes about 100 milliseconds. How does it work? They've built a 3-tier cognitive architecture. Think of it like a human brain. The subconscious layer handles the automatic stuff, like when you catch a ball without thinking about it. The cognitive layer is the deliberative planner. It thinks about what to do, imagines different outcomes, and chooses the best path. And the meta-learning layer is the part that reflects on its own performance and adapts. It's not just learning, it's learning how to learn. The key insight here is world models. Instead of learning purely through trial and error in the real world, which is slow, expensive, and potentially dangerous, the system builds an internal model of how the world works. It can then practice in its own mind, running thousands of simulated attempts for every one real-world try. This reduces real-world interactions by up to 40%. That's 40% fewer crashes, 40% less battery drain, 40% less wear and tear on hardware. And it does all this with inference latency under 50 milliseconds on a device that's about the size of a credit card. This is a big deal. Most AI today runs in the cloud. You send your data to a massive server farm. It processes there and sends the result back. That introduces latency. It requires constant connectivity. It raises privacy concerns. Edge deployment changes all of that. The intelligence runs locally. The system can react in real time. It's not dependent on a server in some distant data center. But here's where it gets even more interesting. The same pattern we're seeing in edge deployment is also emerging in how we think about AGI itself. For years, the field has been split into warring camps. The logicists say intelligence is about symbolic manipulation, like a giant reasoning engine. The emergentists say it's about neural networks learning from data, like the human brain. The universalists say it's about Bayesian inference and compression, like AXI or Solomonoff induction. Each camp has its champions, its conferences, its funding sources. The artificial scientist paper is essentially saying, all of you are wrong, and all of you are right. No single paradigm is sufficient. You need a hybrid. You need the symbolic reasoning of logicist approaches combined with the pattern recognition of neural networks, combined with the mathematical frameworks of universalist approaches. It's like saying you can't build a car using only wheels, or only an engine, or only a steering wheel. You need all of them working together. And here's where things get really interesting. The EDGE General Intelligence paper actually builds something like this. Their three-tier architecture is essentially a hybrid. The subconscious layer handles fast, reactive control like a neural network reflex. The cognitive layer does deliberative planning using learned world models, like a symbolic reasoning system, and the meta-learning layer adapts and reflects on its own performance, like a self-improving system. They're not just talking about hybrid architectures. They're building them, and they're getting them to work on a device that fits in your hand. Now, this is all happening against a backdrop of the field final.